Hi, Joan. How are you doing?
I'm good, thank you.
So, did you go through last class? Anything? Did you go through? Do you remember last time I taught you a method to calculate percentages faster? Do you remember?
A little bit, yes.
So, let me ask you, what is 40 percentage of 80? 80, 40 percentage of 80. What is 10 percentage of 80?
8.
8. And what I asked is for 40 percentage of 80. That means 10 into 4. 10 percentage into 4 will give you 40 percentage.
Yeah.
So 10 percentage of 80 is 8.
Yeah.
8 into 4 will give you 32. Right? So 32 is
so I get
40
it.
percentage of 80. Now you get it?
So basically 80 divided by 10 equals 8.
Yeah.
And then 8, so 40 divided by 10
Yeah.
equals 4. And then 8 times 4 equals 32.
Yeah, simple. So you don't have to like lose your time finding percentages anymore. The class, I'll ask maybe 1 or 2 questions regarding this. So let's see, let's go to the substitution method in base levels so that you don't get confused with the elimination methods. Yeah, you can see my slides, right?
Yeah.
Yeah. So for, the thing that substitution method, why I say it's important is that in real life, more than elimination method, we use substitution methods everywhere.
Yeah.
For example, have you gone for any trip with your parents somewhere? So have you ever asked your dad that how much time will it take to reach there?
Yeah.
And he must have answered correctly, right?
Yeah.
So how do you think he answered it?
I don't know.
It's quite simple, right? He might be knowing the distance from your home, maybe to France,
Maybe.
where you're going. And so he might know the average speed at which he's going to drive.
Yeah.
Yeah. So we have this formula called to find the time. We know that speed, time is equals distance into speed.
Yeah.
So knowing the distance and uh, the distance between them and the speed with which we are going, he can actually calculate the time, right? By substituting.
Yeah.
So what he actually does is there that he made a basic equation of, he know the basic equation, speed equals distance into time, and he substitutes the value for distance and speed there so that he can get the value of time.
Yeah.
So that's what basically we do in substitution methods.
Yeah.
We might have like 2 or 3 unknowns in our equation. So we find a way to eliminate, like substitute the value of, make the equation in such a way that we can substitute one variable into another.
Yeah.
Or maybe we can substitute some value to the variable so that we can solve the equation.
Yeah.
Okay, so before going, let's take an application case. Like I just wanted to know whether you can make this word problem into an equation. This is actually the basic of algebra. Whatever you study in algebra, if you have to use it in real life, we need to know how you make whatever you think into equations. That's the most important thing.
Yeah.
So can you put this into some equation?
Sam has $2 less than Alex. How do we write this in an equation? So.
Okay, I'll give you options, 3 options you can choose from.
Yeah.
Which do you think is the right equation? It's quite confusing because it's all close. Equations are close.
Yeah. I think it's the second one.
Yeah, right. It's the second one. So how do you think it is? Like, we know that in the question it's given, Sam has $2 less than Alex, right? So if we have to equate it in an equation, we put the whatever the dollars Sam has as a variable S onto the left hand side,
Yeah.
and whatever money that Alex has as a variable onto the right hand side.
Yeah.
So what we do here is, if we know that Sam has $2 more than Alex,
Yeah.
so if we actually subtract that $2, then it would be equal, right?
Yeah.
Can you move this into an equation?
Okay. On our street, there are twice as many dogs as cats. How do we write this equation?
What was the question here is, on a street, there are twice as many dogs as cats. Twice as many dogs as cats. So that means it's given that the number of dogs is twice as that of cats, right?
Yeah.
That means if you multiply, uh, that means the number of dogs is twice as that number of cats. So if we have to equate in an equation, we have to make the number of cats double, right? So that it becomes equal to that of dogs.
Yeah.
Yeah. So which equation do you think?
The second one then.
Yeah. In the first, what does the first equation imply? The first equation imply that twice dogs is equal number of cats. That means that's actually the opposite to the whatever the question is given, right?
Yeah.
Whatever is given to us. Okay. So can you make this one now? This might feel a bigger question, but I think it's much more simpler. This is the part where we actually start substituting, the substitution method. You got any idea to make some equations out of this question, first of all?
S
So that,
minus A equals 4.
yeah, that's right. And we have one more equation,
What?
and it's given that they together have played 12 games. Sam and Alex together have played a total number of 12 games, total of 12 games.
Yeah.
So we can see, if we take S as number of games played by Sam and A as number of games played by Alex, we can say that S plus A equals 12, right?
Yeah.
So that's our second equation.
Mhm.
So now we'll see the power. So as you have said, the number of games Sam played equals four more than Alex. So if we add the number of games 4 to Alex, their games become equal.
Yeah.
It's the same equation that you told. It's S minus A equals 4. It's the same thing.
Yeah.
So this is the second equation, S plus number of games played by Sam and Alex equals 12. So we have the two equations. Now can you, here's the part. Now we have to solve this. How can we solve this? Using a substitution method. What we have to do here is, since we have two unknowns in this equation, we have to try and get rid of one unknown so that the thing gets easier.
Yeah.
So let's look this first equation. S equals A plus 4.
Yeah.
So from this we know that variable S equals nothing but A plus 4.
Yeah.
So why don't we substitute that for S?
A.
A plus 4. See, we have the first equation, S equals A plus 4. So we can write it here, right? So instead of S, we can write A plus 4, right?
Yeah.
So you substitute that here. So A plus 4.
Then maybe it could be like 2A plus 4 equals 12.
Yeah, that's it.
And
that's the
then
substitution.
2A equals 12 minus 4. 2A equals 8,
Yeah.
and then A equals 4.
Yeah, that's all. So you know substitution then.
Yeah.
That's all. Substitution is the simple. Like we found simplifying through substitution, we found that Alex played four games.
Yeah.
So how many games did Sam play?
4 more games than Alex did.
Yeah. So that means Sam played 8 games. Yeah, simple. Here's a question. Can you solve this graphically?
Where do I graph it?
Yeah, just like you don't actually need a graph to solve that. Like you can just draw an X and a Y and just plot up to 5 numbers.
X equals 2.
Right? We have 2 equations, x plus y equals 6 and x minus y equals 4, right?
Mm-hmm.
So what of his first equation is x plus y equals 6.
Yeah.
We have to give different values for x and y so that the result remains 6.
Yeah.
So what can be the values for x and y?
2 and 4.
Yeah, 2 and 4. And 3 and 3 can be, right?
Yeah. 1 and 5.
Yeah, 1 and 5.
And 6.
And those things can get inverted also. We can give value for x as 1 and y as 5. And same ways we can give value for x as 5 and y as 1. We can invert the values.
Yeah.
Yeah. So that we make a table. Like maybe plot 3 values.
Yeah.
Right? When x equals 0, y equals 6.
Mm-hmm.
X equals 2, y equals 4. So 2 plus 4 equals 6. And I've inverted the value here, 4 and 2.
Yeah.
And just like that, we have the second equation, x minus y equals 4. So we find different values for x and y here too.
Yeah. And we plot the coordinates.
Yeah.